Alright, so here's Chapter 3, Problem 8 from R.C. Hibbeler's Mechanics of Materials. It's a good little trigonometry practice problem, as well as gives us a little introduction to this A36 steel material. Because of the material, you know that the yield strength is 36 KSI, and I had to look up the modulus elasticity 29 KSI. And in this problem, you really have to do a statics problem before you can get into any sort of mechanics of materials per se. I drew this little FPD of CB so that we can see how we need to find the force AB and what that equates to. So let's take this moment about point C so that we can figure out FAB. Counterclockwise being positive, set that equal to 0. So we have a negative 900 times 3 plus the 9 feet away for FAB. We only want the y component, so we can see that's sine of 30. Or from the original, without even using the 60, 30, 90 triangle, you can just see that this is the same as what's one by cosine of 60, yeah? Which is also equal to 1/2. We simplify this down, we have negative 2700 plus 9 FAB sine 30, or 2700 divided by 9 times sine of 30, and we find that FAB is equal to 600 pounds. It's equal to 600 pounds. Negative 900 times 3. Divide that by 9 times sine of 30. We'll get the 600 pounds. So now we're ready to move on to some actual mechanics of materials. Well, this assumed direction was correct, so we know that the wire was experiencing some tensile force. In other words, the wire is going to get stretched out, right? We can take this force and we want to divide it by an area so we can figure out the stress right there. The area of the wire is pi over 4 times the diameter, inches squared. As always, units kind of help to the direction you're going in. We saw that this was in KSI, and so inches. So obviously, we're going to be working with KSI, PSI, kips, that sort of thing. Kind of helps us get along in the direction of the problem. So we take our 600 pound force, divide that by pi over 4 times 0.2 squared, and find that we have a 19.1 KSI tensile or stress. Now the significance of this is that because this is less than the yield strength, it allows us to use this equation I'm writing up here at the top. And that's how we're going to find our strain, because we know this value and we were essentially given that value, so we can find this one. Okay? So our 19.1 KSI divided by the 29 KSI equals 0.6586 2069. 2069. But this should have been times 10 to the negative 3 KSI. Excuse me, it should have been times 10 to the 3 KSI, because now for our strain, we're going to get 0.6586 times 10 to the negative 3 inch over inch. I was looking at my notes because I knew something wasn't right, and here we see that's what it was. So at this point in the problem, it's good to go ahead and figure out what the length of AB was. Again, that's why this is good trigonometry practice. SOHCAHTOA, right? Sine of some angle is equal to opposite over hypotenuse. We know this angle is 60 degrees. We want our hypotenuse. So h sine of 60 equals opposite, which we know is 9 feet. H is equal to 9 feet divided by sine of 60. 9 divided by sine of 60. which is equal to 10.392304. I like to write out these decimal points when I'm doing the intermediate calculations, just so I can make sure I'm not getting anything trivial wrong. Of course, that's in feet though, and we're working with inches here. So let's multiply that by 12. So the original length here is L naught is equal to 124.7076581. And we want to determine how much it stretches when the distributed load acts on the strut. It's important to read the question well. We're not finding the new length, and that's our answer, but we do need to find the new length, subtract the original, and we can figure out how much it stretches by doing that. So to figure out how much it stretches, we're going to use this right here. 1 plus strain AB times L naught is equal to the new length. I'm going to scroll down a little bit here. So we have our 1 plus 0.6586 times 10 to the negative 3. Let's multiply that by 124.7076581. That gets us our new length, which is equal to 124.7897906. Now we can subtract the original from that. So let's write out the whole thing just for simplicity. That's going to equal our answer right there. Subtract 124.7076581. And so our change in length, or our answer, is 0.082132464. Suppose it asks for like 4 sig digs. 8213 inches. Box your answer and you're good to go.